Okay, so I was really wanting to do this video in Zig, but AVR support is kind of in a broken state right now as of Zig 014. So I don't really want to wait any longer. So we're going to use TinyGo and talk about building embedded applications with Go, again, using TinyGo. So I have this plant, and I want to monitor the soil to see if the soil needs more water. So I've got some tools to help me with this. I've got sensors here, soil moisture sensors. I've got an LCD screen that will connect as well. And then I've got an Arduino Uno as well setting on my desk. I have a breadboard. I'm probably just going to be cheeky and not use my breadboard and just try to shove everything into existing Arduino pins. But yeah, let's talk through what we're building, and then we will also write some code to make this happen. And I'll talk through flashing that code to your AVR device and everything else you need to know. Okay, so on my screen, I have this tool called Circuito.io. I've not used this before, but I thought this might be helpful to just try to illustrate how this is going to fit together. So we have an LCD screen. It is a, actually, I think this is it, a 16 by 2. That looks spot on. Oh, it's actually really nice that it helped with the circuits as well. And then we also have a soil moisture sensor. This is not exactly what we have, but it's pretty close. So let me actually remove this, and we'll just take a look at the screen. So this module, not this one, this one. Let me open this right quick. Some ASMR for you. Okay, so this is exactly the same thing that I have on the screen, which is really fantastic. So we can see here, where's my camera? There. So that is exactly what you're seeing on the screen. So the key thing here is, let's zoom in a little bit. And the key thing here is that our ground connects to one of our ground options. We have a 5-volt going to our VCC from the looks of it. Yep. And then we have our SDA and SCL ports going into A4 and A5. I am not a hardware expert. I would not be the right person to explain all of these and how these ports fit together, but the short is that SDA and SCL is a way to communicate across devices. So if you are interested in learning more about that, I strongly recommend Googling SDA and SCL and learning more about that protocol. Okay, so this is really straightforward. This is what we'll connect. We'll use jumper cables. So we've got, jumper cables might not be the correct term, but let me grab some cables. So we have cables like this. So female end, male end. And we will plug the female end into our board right here. Right there. And then we'll follow the male ends all the way down to our Arduino. So once we have those plugged in, the next thing is the soil moisture sensor. So the one that I have is, let's see. I have this one right here. It's really straightforward. There's some information on that. So the key thing here is a ground, power, and then our input. I was trying to see if there was an Arduino example. Actually, there's a video with an Arduino example, but in my case, we need to ensure that our soil sensor is going into a 5-volt, a ground, and then what's the last one going to for us? Oh, our A0. So A0 is going to be an input, an analog input for us. So we'll take that approach and get started. Sorry if the editing is choppy on this one. My dog has decided that now is a great time to play since she heard me filming a video, so she's been all over the place. Once we have everything together, I don't know if I have a great way to show this, so yeah, my cables aren't very long. You know what I'll do? I will snap a picture and I will upload that as a part of the video. Hey, it's me again. Just as a reminder, when working with electronics and electricity or anything that has an electrical current running through it, you should always try to be safe. So make sure you are connecting your grounds properly. Make sure that you're operating away from water. I know this is going to be a bad example here in a minute because I've got a cup of water that we'll use to test the soil moisture sensor. But just in general, try to make sure that you are being safe when working with electronics. Okay, and so just to recap, we've got our soil moisture sensor connected to a 5-volt, a ground. Don't forget to connect your ground. And then our A0 pin. And then our LCD display is following the model that we have here, which is the SCL connected to the A5, the SDA connected to the A4, the VCC connected to the 5-volt, and then the ground, of course, connected to the ground. Just looking at this as an example, I'm using this ground right here. I don't know if you can see that very well or not. I hope so. I'm using this ground right here to connect to the soil sensor. I have another 5-volt. So my board is slightly different than the Arduino Uno. It is a Inventor IO Hero 3, I think. It's more or less the same. It does look like I have slightly different pins here. So I have another 5-volt pin on mine that I'm using for the soil moisture sensor. And then I'm using this ground for the soil moisture sensor and A0 for the soil moisture sensor here. So the rest of this matches the pattern that you're seeing for the LCD screen. Okay, let's get to the fun part and actually write some Go. So I'm going to create a new directory here called TinyGo soil. I'm going to change into TinyGo soil. I'm going to touch main.go because we're going to be operating on a main.go file. Let me make this a little bigger for you. Okay, and let's go ahead and get started on our main.go. Wow, this is massive. Hopefully this is legible. So this is going to be our main package. We're going to import a couple things. So on TinyGo's website, under their Get Started section, you can see how to install and take a tour and an overview and all of those fun things. So on a Mac, if you haven't, you'll brew tap TinyGo org tools and then brew install TinyGo. There are other ways to install it, but if you're using brew, that is without a doubt the easiest way. So that's what I would recommend. This hardware tour is really nice. This is similar to a tour of Go, but it is a tour of TinyGo. And what's really cool about this is you can modify the code here, and you have a little virtual device that this is running on. So you can change it as well. So if you want to see what this looks like on a Raspberry Pi Pico, and you let this compile and run, you can see that the LED flashes here. Plus, you can look at all the pins, which is really nice. This example program is actually really contrived. So it is a blinking light. Most boards have a built-in light on them that blinks. With the case of the Arduino Uno, though more or less what we're using, you can actually, there's a pin that stays in sync with the light. So every time you blink on a light, it'll send on that pin. So if you want to, you can connect to that pin and instead, blink an external LED or something. Oh, okay. I don't need to get too much into the tour. You should go through this on your own if this is something you're interested in. You'll be able to learn a ton of useful information about it. But the key thing here is that we need to import the machine package. So we're going to do that. So if I go over here and I import machine, if I can type it correctly, I'm going to go ahead and pull in a couple more imports that I know we're going to need. We're going to be reading from our sensors, and those are going to be U16s. We need to convert those to strings for display purposes. We want time because we want to work with a timer. And then the big one, I want tinygo.org/x/driver/HD44780I2C. So what is this number? Okay, so this is a LCD display. The LCD displays that we have are compatible with this specification, so we can use this driver and take care of programming that LCD screen as if it were an HD44780I2C, or HD44780, I should say. Okay, if we want to do anything with the LED, we can. So, that's an option if we want to get into that, but Okay, so we're going to go ahead and start with a func main, just like normal Go. I'm going to go ahead and print line hello TinyGo. And the reason I'm doing this is one of the very first things I want to see to prove that our code has successfully flashed and it's running like we would expect. I want to be able to monitor this embedded application. I want to be able to monitor my Arduino application and make sure that it is actually running. And a print line at the very beginning of our function here is a great way to do that. Okay, we're going to initialize ADC. So if I go machine.init ADC, and sorry, one of the tricky points that I've ran into here is that my autocomplete for NeoVim is not very TinyGo aware, and I'm not entirely sure what I need to do to fix that. So you'll see some squiggles, you'll see some things that look like errors. Just trust me on this as we go, and we'll debug together without the help of an editor if we run into that point. Okay, so we're initializing ADC, so we have access to our analog pins. We want to go ahead and get a handle on our I2C because we're going to use that, so we can get machine.I2C0. And then we can go ahead and try to configure this. So I can say I2C.configure, configure machine.I2C config. And, you know, we probably want to handle if error is not equal to nil, because this is Go after all. We could print line something like could not configure I2C. And then we could give that an error. And then we probably want to return since we can't actually do anything else. We are dependent on I2C configuration succeeding. Okay, so we have that HD44780 I2C driver. So let's go ahead and create a new LCD display. And it's going to be HD44780 I2C.new. And then we need to give this machine I2C0 and 0x27. Okay, we can configure our LCD now. So we have HD447 I2C.config. And the key thing here is we just need to give it a width and a height so we know how much space we have to work with. So my LCD screen is a width of 16 and a height of 2, so we'll go ahead and use that. Then we're going to code up a sensor. So that sensor is going to be machine.adc, and here we need to give it the ADC pin. So we have our soil moisture sensor in ADC0, so we're going to just pass in machine.adc0 here. We can configure this, so if we do sensor.configure machine.adc config, and we can just pass in the default value for that struct. And then the next step for us will be setting up a for loop, because we're going to run this continuously. And I want to get the value from that sensor, so I'm going to say sensor.get and store that in value. And then I want to go ahead and clear the display of the LCD screen in case there's already anything displayed on the screen. This essentially clears that buffer and lets us write to a fresh buffer. If we weren't to clear this, it would write a little bit, and then the next bit would be right after that, and then after that, and then after that, and then eventually the buffer would overflow and it would repeat. It's better for us to just clear the display. It'll look a lot nicer. So we can use a couple values here, and I did a little bit of testing with this to get a rough handle on the values that we want. So in my case, it's going to be 16,500. And if the value is less than that, then we can go ahead and LCD print. We're working with a byte slice here. So we want something like soil is fine \n. We can use the value that we have here. So we can do string conv I to A, and then we can int that value and use that. So that should print it for us. So what I'm going to do is yank this, and then we'll do an else here, and I'll paste this, And the key thing here is that we want to say something other than the soil is fine, because it's not fine, right? So maybe soil needs water. And then the last thing we want to do at the very last bit of our loop, we can do time sleep time millisecond times 1000. Or I guess we could have just done seconds times 1, but whatever. It doesn't make too big of a difference. Okay, so I'm going to go ahead and write quit. We have a command called TinyGo. Now that we've installed that from their website, we can use TinyGo Flash. We have to specify a target. So that target is Arduino. Mine's running on this port called /dev/cu.usb serial 11310. And then we want to flash main.go. So how do you know what port yours is running on? So if you run TinyGo help, you'll be able to see all of these commands that can be helpful in figuring that out, or what you can do with TinyGo. I'm scrolling up a bit. Sorry, my text is massive. So here I can run TinyGo ports, and we can figure out what ports are available. So what we see down here is that dev cu USB serial, like I mentioned. So if we try to flash this again, maybe. Oh, we run into an error. We need to go get this package. Oops, and we need to set up a module. So we'll do go mod init github.com/bradseipert/tinygo soil. Now if we do go get tinygo.org, okay, cool, we have that. Let's do our TinyGo flash one more time and see how this turns out. Okay, it's writing to our device. It's flashed to our device, and we have quite a few things going on. So I'm going to try to bring some of this stuff into the camera so you can see it. So I have my soil moisture sensor. You can also see that it's wet. We can see that if I dry this off, the value that I'm working with, I don't know if you'll be able to see this, is, yeah, it's just slightly too tight. Anyways, it says soil needs water 28544 29760. Here's what I'll do is I'll record a clip of me working with this on my phone and upload it as a part of this video as well. But if I take this soil sensor and then I've got a cup right here with a little bit of water in it, and I add the soil sensor to the water, the value that I'm seeing it say now is soil is fine 14912. And if I take it up some, that value changes. So now it says soil needs water 17408. Soil is fine 16192. Soil is fine 14818 13376. And again, we're running this every second, so it's getting an updated value every second. So really the last thing to do is to take our plant and plug our soil moisture sensor into the plant. And if you are a gardener or someone who likes plants, or maybe you're just someone who has a snake plant, you would probably know that a snake plant is a fairly easy plant to take care of, and they need very, very little water in the grand scheme of things. So these numbers may be fine-tuned. You also may think that I don't need to build something like this to take care of a snake plant, or I shouldn't, rather. I just like building things like this for fun. So here we are. I have implanted my sensor into my snake plant, and we can see that it needs water. So if I were to add some water to the plant, it still claims it needs water, but the value has gone down. So the value that I'm seeing is significantly lower. It's about 3,000 units lower. So maybe I'll tinker with the values a little bit more to find a happy medium for the snake plant. Anyways, that wraps it up. That should take care of this, I think. So I will try to make sure that I have this code available somewhere should you like to use it. And then I'll also make sure that there's an example of how all these pins fit together again. So I should have that. You should have already seen that at this point in the video, but I will try to make sure that that's available on the end screen here as well. Thanks, and have a great day.